All right, let's work another example problem. And the situation this time is a cannonball is shot straight up at an initial speed of 98 meters per second. What are its velocity and speed after 5 seconds and after 20 seconds? All right, so the first thing to do is let's understand the situation. So a cannon is going to be shot straight up, and so what is the acceleration that's going to be acting on this? After the initial shot, the only acceleration that's acting on it is is going to be the force of gravity. Is going to be our gravity. So let's go ahead and draw our cannonball here. And so initially the velocity vector, we'll draw in our velocity vector is going to be going up at 98 meters per second. So that's our velocity vector. Now what about our acceleration vector? What does that look like? Okay. After it's initially shot, the acceleration that's acting on it is going to be gravity. So it's negative 9.8 meters per second squared. Okay. So it's after the initial shot, the only thing acting, it will be in free fall, but it has an initial velocity. So let's go ahead and let's work through this problem. So what do we know? We know our initial velocity is 98 meters per second, and we know that our acceleration is equal to negative 9.8 meters per second squared. And what are we interested in? We're interested in the final velocity in meters per second. And we also know the time is going to be 5 seconds, and then we'll recompute it for the time is equal to 20 seconds. All right, so we have an equation that involves final velocities, initial velocities, acceleration, and time. And that is final velocity equals initial velocity plus acceleration times time. So let's go ahead and plug our values into that. We're looking for our final velocity. We know our initial velocity is 98 meters per second, and then we'll add to that negative 9.8 meters per second squared. Multiply that by, in this case, 5 seconds. We're going to start with 5 seconds. Okay, let's check our units. Okay, seconds there cancels out the seconds squared there. So we're left with meters per second plus meters per second. So just what we need. Velocity final is equal to 98 meters per second. If we multiply 9.8 times 5, or negative 9.8 times by 5, that gives us 49. And note it gives us a negative 49. Note it's a negative 9.8. So negative 49 meters per second. So our final velocity is equal to 49 meters per second. So after 5 seconds, the cannonball is still traveling upward. But it's lost a significant amount of its initial velocity, but it's still moving in the upward direction. All right, let's go ahead and if we computed this for 10 seconds, one of the things that let's go ahead and just do it. Velocity final is equal to, let's recompute this, and let's actually do it for 10 seconds, and that way you can see kind of get a better idea of the full projectile, or the full path. So 10 seconds, our second squared cancels there. Our velocity final is equal to, when you multiply it all out, 98 minus 9.8 is going to be 0. And so after 10 seconds time, it's at the very top of its trajectory. It's at the very highest point that it'll go. And now after 20 seconds, let's go ahead and recompute one more time. And so we're going to use the same equation, just with a different time interval. So velocity final is going to be equal to 98 meters per second plus negative 9.8 meters per second squared. Multiply that by 20 seconds. That cancels out there. And our velocity final is going to be equal to 98 plus 9.8 times 20, and there we have it. So after 20 seconds, its velocity is going to be negative 98 meters per second. Okay? And there you have it. And so now we can see the velocity of this cannonball at 3 different points in its motion, and the whole time. And so this is a great illustration of an object that is undergoing free fall with an initial velocity.